Hey, Susan, how are you doing? Alright, let's at least turn this music down. Do this. Good evening, good evening. Sorry I'm a little bit behind. I apologize. I apologize if I'm a little bit behind here. Just having a chat for a little while, so I'm here. Good evening to you. Hopefully you're doing really, really well. Hopefully we're doing really, really good. I hope everybody here is doing really, really well as well. I'm doing good. It's been a rather busy day. But everything is now set and ready to go. Gonna get another couple sections in here today, hopefully. Hopefully. Question mark. Hopefully. Lots of question marks, lots of hopefully. So, definitely. Any plans for the weekend there? Hopefully you got plans for the weekend. Nice time to sit and chill and relax and enjoy a grand old time. Susanna, hey, how you doing? The homie for work and homework for sure. Sadness indeed. I don't like homework. All the tears run down your face. What am I up to this weekend? Well, if it makes you feel better, I am doing taxes this weekend. Taxes is going on this weekend. I know that doesn't seem super exciting, but I have the thickest of folders of tax stuff. God, I can't believe I have like 90 some odd documents, maybe nearly 100 documents, and I have to submit to the tax man. So, yeah, I got like a ton of stuff to just like I gotta see my tax guy be like, here, figure this out. And I'm like, it would be F in the chat for my wallet. I'm like, oh man. Ah. By the way, if you weren't aware, tax season has been extended 1 month, so until May 15th. So if you haven't done it just yet, well, you still got one more month to go. So I use that information. That's why I'm doing it later. But yeah, I still won't get penalized regardless. I have to thank the pandemic for. I don't want to thank the pandemic for lots of things, but I guess the extension is pretty. So. What are you doing this weekend there, Susanna? Any plans for this weekend? Maybe just couch surfing for the weekend? I don't know. You've been drawing 24/7. I have a commission. Oh, wow. Holy smokes. A commission due on Sunday. Woof. Well, hopefully that will go well and the prospective buyer will like what they see. I'm sure you're going to do an outstanding job. Yeah, I trust in your ability. It's just you'll do well. You'll do well. Your buyer will certainly like what you have to what certainly they paid for. So better you get at something, well, let me tell you, definitely go far. 100%. All right. What I'm hoping for today, by the way, just to give you a heads up, everybody, I had a few internet issues this afternoon. Hopefully, that won't be an issue here for this course. Uh, for whatever reason, my internet was acting a little wonky this afternoon, but cut out like a few times. So if it happens, do understand that it's something I can't really control all that well, but it's a thing. Oh, hey, ASY. Woo. Man, it's been a while since I've. I mean, I see your name in the thing, but I haven't heard from you in a while. How you been? Today we're hydrating with some milk tea. Good. I know you lurk around quite a bit, but I don't say anything until you want to say something. And you're always welcome to say anything at any time. So, but I hope you are doing very well. And I hope you're at least learning something, at least from lurking around here a little bit. I get a little worried. I'm like, oh, not really saying much, but hey, that's okay. As long as you're learning something, I'm cool with that. Natty, hello. How you doing, Natty? I hope you're doing good, Natty. You got a nice weekend available to you. Got a nice few days just to chillax a bit. Maybe get a little homework in. There you go. I gotta ask KSY if you're doing if you feel like things have been okay for the course so far. I just want to be sure that things are pretty cool with you. So I'm very good, Natty. Thank you. Doing very good here today. Been pretty busy, but we're getting stuff done here, so we'll be working things here. Things have been good. All right, wonderful. At least have you been able to follow along without too much trouble? I hope. Oh my goodness, everybody's coming out of Srabando. Man, I haven't heard from you since like day one. Holy smokes. Holy moly, how you been doing? I see you lurking around too. Okay, it's not like I don't recognize. Again, I don't push the issue, but I hope you are doing well. I hope you've been getting along well for this class. Thank you for the hydrate, by the way. No trouble at all. Excellent. 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 Wonderful. Yeah, trust me, I see you guys lurking around, but I'm not about to push the issue, I'd be like, I want people to participate, but I'd be like, you know what? You do what you do. You've been good. I just enjoy it. I don't talk much, but class has been good. Wonderful. I just enjoy watching, but I don't talk much. I look, I know my face. I know my face is not the easiest thing to watch for 2 hours. But I try and make it as good as possible. All right, we're all in it together. Okay, I promise you that. I promise you that. As long as you know what, you know, it's just good to hear from both of you. Honestly speaking, because you know what, from my perspective, and this is just me talking here. From my perspective, I just like to get to know you guys more. If there's something that I can help you with, or at least put it in a perspective that you can understand. If it's not so clear the first time, then I'd be more than happy to, happy to hopefully help you on those fronts. So again, I'm always here to help both of you. That's been true since day one, and we're 2.5 months in, or actually 3 months in, and that still hasn't changed. So yeah, we're I just want to reach out to both of you and say, hey, you guys are always valued members of this class, regardless if you say something or not. And I want to be sure that both you, KSY, and Srabando, that you guys know that it's I do recognize you out there, um, and I want to be sure that you're taken care of as best as possible. Okay, so um, all right, so you guys just let me know. If you have questions or whatnot, I'll be here to answer them as best as possible. Okay, that's what I'm here to do. What I'm here for. Yeah. Excellent. All right. Well, I hope we're getting ready here because we're about ready to go here with today's stuff here. So let's go ahead and get started, and we'll do some intros. We'll get started. We'll get going here. Let's do this. All right. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today, ladies and gentlemen, we're gonna hopefully finish up chapter 11. Okay, we have sections 11.3 and 11.4 here to do today. We'll see how far we get. If I don't suspect we'll take up all the time, but it just depends on the pacing here. It shouldn't be all that hard to do, in all honesty. In any case, however, let's talk about again. We're going to be looking at, say, here today, talking about more hypothesis testing here with two different perspectives here once again in chapter 11. So it'll look fairly similar to what we did here last time on Monday. So there's not going to be like a whole big difference here, but of course some of the small little bits here, of course, are going to make the big difference, like the test stat and what we use on the calculator and whatnot. But a lot of the things that we've talked about here already should feel fairly familiar to all of you by now in some capacity if you have those in the notes. All right. So I kind of whipped up the handout here for today. So let's go to the big board here. Let's see what we're working with. I have no idea what we're working with, but we're something. All right. Anyway, maybe. All right. So let's look at the very first question that we have here, and I'll make this a bit bigger. Actually, there we go. All right, so let's look at question 1 here. This is for section 11.3. It says, how can we do hypothesis testing with two different means and no known population standard deviation? So we're not given a population standard deviation. We're given two different means, and in this case here, these two different means are just going to be basically two independent samples, all right? So they're going to be completely independent of each other, and you could ask 200 people some question, and you can ask another 200 people the same question. Again, two different results, and then you compare and contrast the two to see if you can make some sort of conclusion. Now, let's take a good look here at the steps. And again, these steps here should look fairly familiar, as basically I went ahead and just essentially copy pasted and modified a few things to make it look nice and neat. All right, first things first here. Step 1, determine the null and alternate hypotheses. Now, the difference here in this case is that we have a set null hypothesis. We have a population, I accidentally miswrote this. This should say I should have a population mean of group 1, not population proportion, pardon me. So we should have a population mean here of a group number 1, and then we have a population mean here being equal to group number 2. So let's say we asked a question here. We says, do you like brand A? You ask a bunch of people the question, maybe go to another side of town or maybe go to another city. You say, hey, you ask the same amount of people, say, do you like brand A? And you're like, all right, and then you get some results and you say, make the assumption that they're both equal if you assume that they both have the equal amount of support for brand A, whatever. All right, now, once again, we have the alternate hypothesis here. Now, the alternate hypothesis here is, again, if the first group is less than the second group, the first group is bigger than the second group, or, again, not equal to. Again, just as it was before, wording here is going to be very important, so please be careful about the wording here. So that way you have your bases covered. All right, we determined step 2 is determining the type of test. We're all familiar with that by now with left, right, and two-tail. And then, of course, stating the level of significance. We'll get to the test stat here in just a second, as it is, as you can see here, a pretty nasty formula here. But let's at least get these first three guys down, just as usual, and we'll see exactly what we're working with here in order to find out what the hypothesis test is going to look like here in this instance. All right, so we're going to start off with something nice and simple, okay? Something not so crazy. So let's go to I'm going to go to the textbook here. Actually, yeah, okay. All right, so we're going to go here to number 9. Okay. So let's look at number 9 here. And let's go ahead and read this off here carefully. All right, so number 9, walking in the airport. Okay, so do people walk faster in the airport when they are departing, getting on a plane, or when they are arriving, getting off a plane? Researchers Seth Young measured the walking speed of travelers in San Francisco and Cleveland. His findings are summarized in the table. Okay, so he talks about the mean speed, the standard deviation that he found, and of course the sample size for each, as you can see here in the table. Now, what we're going to look at here for this example is we're going to go ahead and look at letter C. Letter C says, do individuals walk at different speeds depending on whether they are departing or arriving at the 0.05 level of significance? Okay, so we're going to want to set up the first three parts here to this problem, all right, first and foremost. All right, so let's go ahead and do that right now. Go ahead and set this up here appropriately. All right. What number? 9. No. All right, so let's go to step 1. Now, here's what's nice about the null hypothesis here. Now, the null hypothesis here is static, okay? So this null hypothesis isn't going to change, right? So no matter what this thing says, I don't care what this says. But what I do know is that there's two groups, like one from San Francisco, one from Cleveland. I said, fine, whatever, that's fair. But this is going to be static in nature. So it's like, okay, the mean of the first group is equal to the mean of the second group. That's what we're going to go ahead and assume here, that mean of group 1 is equal to mean of group 2. And if it helps, again, just to be on the safe side here, what will be helpful here is just to label your groups. So again, in this case here, you could have, I'll just put it up here. Group 1 is San Francisco, so San Fran, and group 2 is Cleveland. All right, so those are our two groups here. In this case, that isn't hard to figure out. All right, fine. Actually, let me check this out here. Oh, actually, I got that backwards. I'm sorry. That again. Sorry, I looked at the wrong context here. Kind of important. We're going to make group 1 here be departures and arrivals. So let's do it that way. Departure and arrival. Those are our two groups here according to the question. So I thought it was both airports, but it's actually just departure and arrival. All right. In any case, we'll have group 1, group 2. All right. Now, let's look at the question here at hand. All right. We have group 1 departures, group 2 is arrivals. Now, what are we going to have here for our alternate hypothesis here? Again, our alternate hypothesis is one of two things. It's going to be either, again, less than, bigger than, or not equal to. So just like it has been before in the previous sections. So what do you guys think? Do you think it's less than, bigger than, or not equal to here, according to the problem here for number 9, part C? So using the wording in number 9C, here we go. What is the alternate hypothesis here? Less than, bigger than, or... Eddie says not equal to. Mazdi, hello? Eddie says not equal to. Anybody else want to chime in? You agree with not equal to? All right. Let's take a look here. It says, do individuals walk at different speeds depending on whether they are departing or arriving? So it says, do they walk at different speeds, not bigger than, not less than? So indeed, that's correct. The answer is not equal to. Okay, good. All right, fair enough. Now, let's take a look at the next part here. What type of test do we have here? So I agree with the not equal part here, but what kind of test do we have then? Two-tail. Okay, good. That's right. So remember, not equal means a two-tail test. All right, so of course we'll come back to this here near the end of the problem, just as usual. but a two-tailed test indeed is true. So that's correct, Natty. Very good. And we'll go ahead and write down our level of significance here. So our level of significance here is going to be 0.05. So that's fine. That's just given to us in the problem here. No need to go ahead and find it, because there it is. All right. Now let's go to the next step here, which is going to be the test statistic. So this right here, as you can see on screen, is the formula here for the test stat. Now, obviously, I'm not going to lie. Of course, it looks really, really ugly. Okay, let's not kid ourselves here. It looks pretty bad. All right, so and for pretty much what we are, I'll be adding a note to this here. Yeah, it's super ugly. Okay, and he's like it's super ugly like your face, and be like, yeah, I kind of half agree with that. The other half told me, eh. It's okay, Natty. I'm just revealing your true feelings. It's fine. The truth must come out. It must be set free. It's very important. Lies. Make a poll. Who thinks I'm ugly? Yes. The only reason why I think you're attractive and very charming is because I'll get a good grade out of this class. I'd be like, yes. Yes, this is the best way to flatter me. Otherwise, when the day comes when I'm no longer in this class. Yeah, you're just going back to being ugly. All right, very good. Go be your hermit self, you outcast. I'd be like, cool. At least I've fulfilled expectations. Alex! Alex, dude. Man, thank you so much, Alex, for the sub. Holy smokes. How you doing, mate? I've not been on lately. That's okay, man. Hey, I know you've been doing your thing. Everybody lives a life. Been working abroad. That's wonderful. Where are you at, Alex? Where are you at? You've subbed for 5 months. Holy smokes. You subbed to this channel for 5 months. How the heck does anybody want to sub to me for 5 months? I still don't understand this. I'm very confused about why people want to sub to me. But where abroad have you been, mate? I gotta know. Where have you been? Which country did you get the work in? Out of all curiosity, my friend. Nepal. Holy smokes! Wow, Nepal for 6 weeks. Wow, doing work out in Nepal must have been very nice. How's the weather? Is it little cold considering it's more up in the mountains, of course? But that's a very unusual place to be stationed at. Wow, I wasn't expecting Nepal. I'm gonna be honest with you. So are you back home now, Alex? Are you back in the UK? Rather pretty too. Altitude is, yeah. Well, if it's anything like Denver, rather pretty good altitude. Yeah, the altitude stuff it takes a little getting used to. Like when you're climbing a mountain and you really have struggle breathing, that can be a thing if you're too high up. Yeah, I can see that. That's totally true. But did you have a nice time? It sounds like you had a nice time though. Back now for a month. Back mid-May for climbing season. Ooh, ooh. So are you gonna? Which mountain are you trying to climb? Um, you're up there in the Himalayas, so you're up in Nepal. So, um, is there a particular mountain you're gonna try and climb for mid-May? Obviously everybody knows of the two most famous mountains up there, being Everest, and K2. But I don't know if you're a super seasoned climber or not to go ahead and challenge those two mountains. I mean, wow, jeez. Last mountain I climbed was, well, um, what was the last mountain I climbed? Oh yeah, that was my bed. It was a struggle bus to get into my bed. Very large mountain to climb through. I tell you, this is the best hermit response ever. Won't have to climb anything if it goes well. I work for an expedience company. Okay. 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 Wow. Very nice. Very nice. That's awesome, dude. That's awesome. That's super awesome to hear. Wow. Amazing, man. Amazing. Much love to you, my dude. Much love. All right. Um. Yeah, I gotta do a test stat at some point. Man, that's too cool. It's too cool. All right. So here's the test stat here. We have the mean of group 1 minus the mean of group 2 minus the population mean of group 1 minus the population of group 2 divided by the square root of this the standard deviation of group 1. Oh, I forgot to put S1 and S2. That would be kind of a thing. That's kind of a problem. All right, let's put that in. This is how I make up my stuff, by the way. So if we wanted S1 here, S1 is going to be the standard deviation. I only climb when the Browns. Oh, okay, that's fair. That's fair. When the brown stuff hits the fan for the climbers, very good. So S1 here is a standard deviation of group number 1, and then S2 will be the standard deviation, the sample standard. Actually, I should say sample standard deviation. Come back. Go. All right. So this is what we have here. I guess I'll put one more note in regards to this here. I'm not sure why I kind of included this here, but the book kind of makes a distinction. That is, this U1 minus U2 thing that we have here. So this guy here, can't you see? U1, so U1 minus U2 is going to be equal to 0. So we're going to make the assumption that U1 minus U2 is going to equal 0. So technically you don't have to put anything there, but it's just one of those things that they kind of leave in the book there. And the reason is because you assume that they're both equal to each other at the very beginning of the problem. Now, if this thing were faster, I would let you know, but for whatever reason, it decides to be super slow. Come on. Come on. Yes. Be good. Oh my gosh. So slow. Come on. All right, let's try from the top and see if that works. No, that's just a slow one. I don't make this stuff up. This is exactly how I do things. It's this slow. My computer, man. Here you go. Wonders of technology, and it's like copy paste. Yeah. This is what you get, bro. I'm like, oh, is that so? I'm like, well, thanks. You're the best. How am I to tell you that I don't like you? Oh, man. All right, there we go. Better. There we are. That's what I wanted. That's what I wanted to see. Perfect. All right, there we go. All right, so there is every meaning behind and under the sun. Now, let's go ahead and take a look here on how to do the test stat and do the p-value here Again, just for the purposes of this example, I'm just going to go ahead and point out the necessary numbers that we're going to need here for this problem. Okay, so I just want to point that out here so that way you can see what's going to be going down. So let's go ahead and take a look back at our problem here. Okay, and so we'll have departures again be group 1, arrivals here will be group 2. So again, x1 bar here is going to be the mean of group number 1, so that'll be 260. X2 bar here is going to be the mean of group 2, which is the arrivals, so that's 269. Right. Next is going to be, as you see, the standard deviation, so we'll have S1. Standard deviation of group 1 will be 53. S2 will be 34. And then finally, sample size here. First sample size here is going to be 35. And the sample size for the other one here will be also 35. Okay. So you can enter this into the formula if you wish. Again, this is probably one of those things I'm going to show off once, but probably not again, just because it would take a while just to kind of write in all the numbers, as you can clearly tell from the very ugly formula that we have here. So, but in any case, I'll do it once and then probably won't do it again. We'll just have the calculator do it in our stead. All right. So, what would be our test stat here? Our test stat is let's say we have x1 minus x2, so we have 260 minus 269. Since we're assuming the last part is 0, we're just going to have that stuff up top. Then we'll have the square root of s1, so that's going to be 53 squared divided by 35 plus 34 squared divided by 35. And that's going to be our test stat in a nutshell, is basically going to look something akin to that. All right. So that's all well and good. That's fine. Okay. Well, let's get to the real meat and potatoes of what we want to be looking at here, and that's going to be step number 5, which is going to be using our calculator to find that particular p-value. Okay, so what's the p-value here we get in this case? Well, we're going to need to use the calculator for this, all right, as we have a lot of information to go ahead and enter in. Now, what we're going to be doing here is we're going to be using the two-sample t-test here. So two-samp t-test is what we're going to be using here in this instance. So let's use the two-sample t-test here for this guy. All right. Okay. Now, in order for us to get this to work properly here, again, let's take out our calculator here. Give you guys a second to get your calculator out. So I'll wait like 5-10 seconds. If you have it out already, then you should be good to go. All right. So we'll go ahead and hit the stat key here. Hit the stat key here. We're going to go over to tests. All right. And what we're going to be doing here is we're going to go ahead and go underneath again, two-sample t-test. So as you can see here, again, two-sample t-test, which is going to be number 4. Okay, so number 4 here, two-sample t-test. Let's go. Okay. Okay, so let's go down to this guy, and we're going to need all the pieces of information that we talked about before, by the way. So you could see how much information we need, every single piece of information. So again, there's data and there's stats. What we want here in this instance is we want stats, okay? That's what we want. So if we're going to do stats here, we're just going to enter in all those stats that we have here from step 4. So we have x1, which is 260. Okay, for some reason clicked on. We'll put in S1, which is going to be 53, N1, which is 35, X2, which is 269, S2, which is 34, and N2, which is 35. And of course, just as usual, we talk about the type of test that we need to be working with here. And as we stated earlier, that type of test here is a two-tailed test. So that being a two-tailed test, we'll go ahead and highlight the very first one we see there. We'll go ahead and enter. Now you'll see this option here for pooled. Just leave it on no. We're not going to touch the pooled part here. You'll never work with this here, so don't worry about it. And we'll go ahead and hit calculate. Okay, so underneath the two-tailed test, we end up with a test stat, and a p-value. All right, so let's take a look at that and let's see what we got. All right, so looking at this here carefully, our test stat here specifically is going to be negative 0.8456. Okay, so negative 0.8456 is going to be our test stat here, which is this t equals. And our p-value here is going to be 0.4013. Okay. All right, so we got 0.4013 for our p-value. Perfect. All right, we're all set to go. All right. Before we get moving here, I want you guys, anybody who's working with the calculator here, go ahead and type done in the chat if you got exactly what I got on my screen here. I want to be sure everybody got the same values here. If you got these same values that I have on the screen, please type done in the chat so I know that we are on the same page. Okay, great, great. All right. Again, if you do have questions, please let me know right now so that way we can cover that again. Otherwise, I'll move forward. Okay, let's move forward then. Okay, so the last part here is just our regular last part that we normally deal with. Again, we're going to compare our p-value with our level of significance. All right, so the same thing applies just as before. So just as before here, again, if the p-value is less than the level of significance, reject the null and accept the alternate. Otherwise, accept the null and reject the alternate. So again, we just ask the same question here. Is 0.4013 less than our level of significance, which I believe was 0.05? Yes. Step 3. Okay. So is 0.4013 less than 0.05? Yes or no? So yes or no is 0.4013, pardon me, less than 0.05. No, right? So the answer to this question here is no. 0.4013 is not less than 0.05. So what conclusion can we make here in this case? What conclusion can we make here? That's going to be our final answer to this problem here. You got one of two possibilities, all right? So it says accept the null and reject the alternate. Okay, that's correct. Good. All right, good stuff. Perfect. All right. Okay, excellent. Okay, any questions about that example? No P. Okay. Okay, so we're going to move on to the next example here. Now, this one here is done with stats. Okay, so let's at least understand that this thing is done with stats. However, there is a different way to actually do this, and that is if we're given a data set. So we're going to look at that example here next. This one here we'll also do together, and really not too hard, but we're just going to go ahead and look at this one. So let's look at number 13 here. So number 13 says is a ramp metering question here. All right, so let's do this. All right, so ramp metering is a traffic engineering idea that requires cars to enter a freeway to stop for a certain period of time before joining the traffic flow. All right, so they did this ramp metering to try and reduce travel times to see if it's effective, and they did this in Minneapolis. All right, so the response variable for the survey was for the study was the speed of the vehicles. A random sample of 15 cars on the highway for Monday at 6 p.m. with the ramp meters on, and a random sample of 15 cars on a different Monday at 6 p.m. with the meters off resulted in the following speeds. So the following speeds with meters on and meters off. Okay, so there we have it. All right, so let's take a look here. It says, are the ramp meters effective in maintaining a higher speed on the freeway? All right, use the 0.10 level of significance. All right, let's start from the top and work our way up, down, whatever you want to call it. Okay. Okay. Oh, that's too high. I should not. Start. All right, good. Step one here, of course, is our null hypothesis. Our null hypothesis will be the same. Again, group one being the mean of group one is equal to the mean of group two. So again, group one here, let's just make this up here. Group one is meters on. And then group number two are meters off. Okay, so easy to paraphrase there. Okay. Okay, now, in this case here, what is going to be our alternate hypothesis? What's our alternate hypothesis here for this question? So take a look at letter B, from 13B. What's um what's our alternate hypothesis? Again, we got three choices here. We got greater than. We have greater than. Okay, good. That is correct. Okay, both the Natty and Mazdi are correct. So again, we're going to have group one is greater than group two. Okay, and again, the key giveaway here is again, are the ramp meters effective in maintaining a higher speed on the freeway? All right, seems fair, very reasonable. Okay, let's go down the line here. What type of test do we have here? What type of test do we have here? Okay, we have a right tail test. That's right. Very nice, Susan. We have a right tail test. All right, that seems fair. Okay. And finally, step number 3, we're going to have a significance level of 0.10, so fine. That's what we're testing over. Seems fair. Okay, now as I stated before here for the test stat and the p-value, we're just going to write in test stat here. I don't need you to write in, all where each number needs to go. What is important, however, I will point out, actually, I do need to make one notation regarding this here. A note. We'll find the test stat and the p-value at the same time, of course. Now, one thing about this in comparison to the other one here, and I guess this is what I want to say here, is that these are two sets of data here. So they're not telling us what the stats are. They're not telling us what the mean of one data set is over the other. They're not telling us the standard deviation. We're going to let the calculator figure all that out once we set it up properly here with these two particular data sets. So I'm not going to actually have any information of which to enter in this case, outside of the data sets that I'm given here in this particular problem. So what I need to do here is if I go to the calculator here, all right, let's go to the calculator. And actually for this one here, yeah, I should probably do that. So, okay, so there you see on the screen, you see the ramp meters on, ramp meters off. So we're going to go ahead and hit the stat key here. And we're going to go over to edit. So that very first option. Yeah, we did have some information here from last time. Again, we want to clear out these lists. So again, hit highlight list, hit clear, and hit enter. Remember, clear and enter. So clear and enter this list. And we used this for last time, so clear and enter that list. All right. So list number one here is going to be all the data in the ramp meters on. Okay, so let's go ahead and enter all those in. Oh, 47. Go. All right, so there are our values, okay, for list number one. And then let's put in the cars here for 2. Okay, so I should have 15 values in for that as well. Okay, just make sure your numbers are correct, okay, before we move forward. Once you have your numbers there incorrect, please type in done in the chat, and then we'll move forward. So you have your data sets entered. Please type in done in the chat once you are finished with entering in the numbers. Wait for a few more people to get finished. Okay. All right. Everybody else okay? We'll move forward if nobody says anything. Okay, we'll go ahead and move forward here. All right, so next what we want to do is we want to quit out. So we hit second and mode to quit to the main screen. Again, this is important so that way we're not entering in any bad values in the table. We're going to go ahead and hit the stat key here once again. We're going to go over to tests. And once again, scroll down to number 4 for a 2-sample t-test. This time, however, we don't have any stats. We have data sets. We're going to go over to data, and then we'll go ahead and hit enter there. Okay, now everything up here should be set up for you and ready to go, but just in case if it's not, we have list 1 here, list 1 being L1. If you don't see anything in there, you can go ahead and hit second and 1, where you put in the first list. List 2, again, same thing here, second and 2, to put in list number 2. The frequencies, you're not going to change anything that's going to not be touched, so leave them as 1. And then finally, the type of test here that we need to acknowledge. And the type of test, we have a right tail test, as we talked about from before. So right tail test, again, we have left tail. I'm sorry, two tail, left tail, right tail. So we're going to cover that last option right there. We'll go ahead and hit enter to highlight that guy. Again, leave the pooled option alone. We're not touching that at all. And we'll go to calculate. See what we get for our values. So it's going to calculate a bunch of things here, but once again here, the only two things that we generically care about is we only care about the test stat and the p-value. Okay, those are the only two things that we are going to care about here in this problem. So test stat here in our problem is going to be that first guy, so that's 1.7133. And the p-value here is 0.0489. Okay. Now with that in play, let's go ahead and do our last step here. So again, just comparing the p-value to the level of significance. Okay, so nothing too crazy going on here. So is 0.0489 less than 0.10? Okay, and this is a yes or no question. So yes or no. Is 0.089 less than point? Yes. Okay, good. Absolutely it is, right? Okay. So if this is true, then what conclusion can we make here? What conclusion can we make here in this case if we have the p-value less than the level of significance? What's our conclusion, ladies and gentlemen? Reject the null and accept the alternate. Okay, so you can't forget about this conclusion. This is going to be your final answer, by the way. So if you forget about this, you're basically losing out on the actual answer to the problem. So that'd be pretty bad. So reject the null and accept the alternate. Good. All right, and that's our final answer with a data set put into play. Okay, are there any questions about that problem there? No? Okay. That sounds fine with me. Okay. No? Okay. Don't want that. Okay. All right. Let's look at one more problem here, and for this section anyway, we'll take a short break and then come back to the next section. So, all right. So the last question here from section 11.3 is going to be, let's go down here, is going to be number 2. Number 2 says, how can we do confidence intervals with two different means and no known population standard deviation? All right, so in this instance here, all we're going to do here is basically we're going to go ahead, we're going to apply the two sample t int, and of course, one of the things that we talked about before with confidence intervals is, of course, knowing what the interpretation behind the confidence interval means. At the end of the day, once we're able to put it together, that's going to be pretty much it for that guy. So let's go ahead and put together a thing here. Let's sit here. Okay, so we're going to do number 20 here. And I need to bring. Okay. Okay. So number 20. Number 20 says the aluminum bottle first introduced in 1991 by the CCL container for mainly personal and household items such as lotions has become popular with beverage manufacturers. Besides being lightweight and requires less packaging, aluminum bottles are reported to cool faster and stay cold longer than typical glass bottles. Small brewery tests this claim and obtains the following information regarding the time in minutes required to chill a bottle of beer from room temperature to serving temperature. Construct and interpret a 90% confidence interval for the mean difference in cooling time for clear versus aluminum. All right, and got a 90% confidence interval is what we need here, and here on the very next column. And I'm going to move my, yeah, that's, no, actually that just appears on the screen here. So here we see clear glass, and here we see aluminum. Talk about the sample sizes, mean time to chill, okay, the sample standard deviation. Okay, perfectly fine. Everything's there. Okay, so what we're going to do here together is we're going to use, again, the calculator here and determining said with the information that we're given. I'm going to go ahead and kind of type this out. So we have our two groups here, by the way, for number 20. Let's at least acknowledge those. Number 20, we have group 1, which is going to be, I believe group 1 is glass. Yeah, group 1 is glass. If I can speak, I'll let you know. Not good. All right. So group 1 here is glass. And then group 2 here is going to be aluminum. Okay. So here what we have is, let's at least write down our three things that we need here. We have our x1 bar here is going to be 133.8. S1, our standard deviation for our glass, is going to be 9.9. And our sample size here in this instance is going to be 42. We have our sample mean here is going to be for aluminum is 92.4. All right. And then our sample standard deviation here for aluminum is 7.3. And our sample size here, it can be different, by the way. So the sample size can be different, so that's perfectly fine. So they don't have to be the same for both of them, okay? They're two independent samples, so to have one rely on the other doesn't mean anything. All right, so all right. So now that we have all the information that we need here from this, oh yes, and we can't also forget, actually, we do need one more piece of information. The confidence level. The confidence level here will be 90%. Okay, so 0.90 for 90%. Go. Good beans. All right. So what we'll do first here, getting on our calculator, we're going to hit the stat key here once again. Let's hit the stat key here. We're going to go over to tests, and we're going to go down to to sample z int. So this guy right here, number 9. Okay, so number 9, to sample z int. Or actually, I should say, did I mix that up? Oh, sorry, not z int. Sorry, t int. Sorry, it should be a t distribution, not a z distribution. Sorry about that, folks. I think that's number 0 then. It is number 0. It is number 0 because I'm being not so smart. Ladies and gentlemen, I'm not smart. This was already well established a long time ago, but now I'm just proving it every day. All right. But I am, or so you thought. Remember, I can fake it till I make it. Yeah. All right. All right, so here we're going to go over to stats. All right. Let's go over to stats. And we're going to enter in all the stats that we have here. So X1 here is going to be 133.8. We're going to have our first standard deviation 9.9. N1 here will be 42. X2 92.4. We have 7.3 and 35, with our confidence level being 90%, 0.90. Let's scroll down here to calculate. Again, leave the pooled option alone. We're not going to touch that. Go ahead and take a look at what we got here. All right. So at least let's at least write this down. Okay. Oh yeah. All right. So let's write down our guy here. So 38.129 and 44.671. Okay. So now the real question becomes is like, okay, well, what's the interpretation behind this this particular problem? This is what we got here for our result after doing the 2 sample t interval here. All right, so let's at least talk about that here really carefully. All right, and let's go ahead and write this down here for number 20 about the interpretation. Again, you can just pretty much use a template here like we have been for most confidence intervals. So in this instance here, we could say B interpretation. We are 90% confident that this case here, that the mean difference between, and go ahead and do that. Mean difference between, and in this case we had, put the context here in this case, the mean difference between glass and aluminum cooling times are between, say are between, oh, is between, I should, is between, and then 38.129 and 44.671 minutes. All right. Okay, good. And that's what we get here for this case. All right. All right, and so that's the interpretation here for a confidence interval there. Now, one thing that I guess to keep in mind here, I guess I'll put in one note here, and that is this. Sometimes you may get this question here, so just to kind of cover our bases here, note if 0 is in our confidence interval, then there is no real significant difference between both groups. All right, so meaning to say, if let's say our confidence interval was like negative 38 to positive 44, you can get negative values here, by the way. So if you had like negative 38 to positive 44, then you could say that there's no real significant difference between glass and aluminum. All right, but if if 0 is not there, then basically that there is a significant difference between those two. Okay, so clearly aluminum cools faster. All right, so yeah, you kind of roll with that. Okay. Questions about that? Any questions? No? Okay. Yeah. Need to check something really fast. Uh, I want just a second, folks. I actually have something to check here for you guys. Okay. All right, that works. That works. Okay. All right, let's do that. All right, I'm going to put a little poll on the very top of the screen here. It's option time. It's up to you. So I'm going to leave it in your care here. So we did finish up section 11.3 here, but I'll give a 50-50 here. Like to end today or finish section 11.4, I'll leave it up to you. I give everybody options because that is important time for you to consider. All right, you got about 15 seconds of which to vote. And then I will take your considerations into account here and enact on it. Okay. All right. So it looks like everybody has voted here to end today's lesson. Okay. So let me give you a rundown here just really quick because we will end off things because that is exactly what you had decided and that's perfectly fair. So we have 4 more sections after today. We got sections 11.4 and 12.1 here for next time. And then we have sections 12.2 and 12.3, and those would be the last 2 sections here of the textbook that I would like to cover. So The last section here will be 12.3. So we technically have like 2 more classes of 2 more sections, and then we're gonna get down to talking about the last test and the final. So we're about there. We're about there, ladies and gentlemen. So we're very close to being finished. Okay. So what I'll do here for next time, by the way, is I'll start here with section 11.4. That shouldn't take us a super long time. That should take us maybe 20-30 minutes, and then we'll get into section 12.1, and we'll talk about that. So that will take up the bulk of the time here for next time. But all right. I hope everybody is okay with that. Does anybody have any questions for me? Sounds good. Okay. Sounds Gucci. Gucci works for me. So does Louis Vuitton. That's the best bribe I could ever get. As long as I can resell it and it's not a knockoff. Okay? Then I'm cool with that. I need one of those plain looking, the airplane looking Louis Vuitton bag that goes for like 6 figures. Yeah, I could go for one of those. I don't even know why you would need a airplane looking Louis Vuitton bag, but whatever. If somebody wants it, I'll sell it to them. All right. All right, ladies and gentlemen. Ladies and gentlemen, I want to thank you all for coming on out here to the stream once again. Thank you so very much. You all are very wonderful. You guys treat me more than I deserve, to be perfectly honest. Thank Alex for his sub. Really appreciate that. Thank you for the follows. All right, I love you all. And again, you guys, what makes this class fun and exciting and wonderful. I wish all of you, thank you so much. Everyone, as I always like to say, stay safe, stay healthy, and most importantly, stay sane. All right. All right. Thank you, Servando. Have a great one. Daddy, good night. Thank you all very much. Take care, KSY. Take care. Take care, Susanna. Lots of love to you. Thank you very much. Everyone, have a wonderful night. We will see you on Monday. Same time, same place, everybody. Have a great one. Take care. Bye.